Welcome to the Deep Dive. Today we're going on a journey into the world of mathematics.
Oh, yeah.
As seen through the eyes of David Deutsch.
Buckle up.
You've given us a collection of excerpts from his writings.
Yes.
And
Stunning stuff.
they're packed with thought-provoking stuff about infinity,
Absolutely.
the nature of reality,
Yeah.
and what math actually is at its core.
So
Start us off.
yeah, what makes Deutsch's perspective on math so unique?
Well, one of his most radical ideas is that math, just like science, is a quest for explanations, not just a way to predict things.
Okay.
He's pushing back against this idea called instrumentalism,
Okay.
which basically says that science can only tell us what we'll observe, not actually describe reality.
So instead of just saying, like, if I do this, then that will happen,
Right.
we're trying to understand the why behind it all.
Exactly. The deeper why.
The deeper why.
Yeah.
Okay.
He uses astrophysics as an example.
Okay.
It's not just about charting stars' positions.
Yeah. It's about understanding the forces that govern them,
Yeah.
their life cycles, the very stuff they're made of.
The nature of them.
Yeah, that deeper understanding is
Yeah.
what truly matters.
So it's like the difference between knowing how to bake a cake because you followed a recipe
Yeah.
versus understanding the chemistry of how ingredients interact
That's a great analogy.
at a molecular level.
Yeah, and Deutsch applies this same thinking to math.
Okay.
He argues that true mathematical understanding goes beyond just crunching numbers and applying formulas.
Right.
It's about grasping the underlying principles that give those formulas meaning.
So for Deutsch, is the why more important than the how in mathematics?
Right. It's not about one being more important than the other.
Okay.
It's about the interconnectedness of the two.
Okay.
He believes that seeking the why, the deeper explanations,
Right.
drives true progress in mathematics just as it does in science.
Makes sense.
Yeah.
But how do we even find those deeper explanations in math?
Right.
Isn't it all based on logic and proof?
Yeah.
Where's the room for questioning and exploration?
That's where Deutsch brings in another key idea,
Okay.
conjecture and refutation.
Oh.
He builds on Karl Popper's work, which argues that scientific progress is all about making bold guesses.
Hypotheses.
Yeah, and then trying our hardest to prove those guesses wrong.
So it's about being willing to be wrong?
It's more about actively seeking out the flaws in our thinking.
Okay.
If a theory can withstand our best efforts to debunk it,
To falsify it.
then we have more reason to believe it's on the right track.
Right.
Deutsch suggests that math progresses in a similar way. We propose new ideas, then try to poke holes in them through rigorous proof and analysis.
That's really interesting.
Yeah,
It flips the script on how we usually think about learning, doesn't it?
it does.
Instead of trying to prove we're right, we should be trying to prove ourselves wrong.
Exactly. It's a more humble approach.
Yeah.
And arguably a more effective one.
Yeah.
This constant questioning and refinement
Right.
is how we get closer to those deeper explanations that Deutsch is talking about.
It's a pretty powerful concept.
It is.
And I'm already starting to see how it might apply to things beyond math and science.
Deutsch would agree with you there. He sees this principle of conjecture and refutation as a fundamental driver of progress
Yeah.
in all areas of human knowledge.
Okay, so we're seeing math as a quest for explanations.
Yes.
Always open to being challenged and refined.
Right.
What else makes Deutsch's perspective on math stand out?
Well, you can't talk about Deutsch without talking about infinity.
Oh, here we go.
It's a concept he explores extensively, and he uses this brilliant thought experiment
I was going to say.
called the Infinity Hotel to illustrate its mind-bending nature.
Yeah.
Have you heard of this?
Oh, yeah, the Infinity Hotel.
Okay.
I've heard about this. Tell me more.
Imagine a hotel with an infinite number of rooms all full.
Okay.
Now a new guest arrives.
Uh-oh.
In a normal hotel, that would be a problem.
Right?
No vacancy. But in the Infinity Hotel, you can simply move every guest down a room.
So the guest in room 1 moves to room 2.
Yeah.
Room 2 to room 3 and so on.
Exactly.
But what about the guest in the last room?
But there is no last room in an infinite hotel.
Right.
That's where things get weird and counterintuitive.
I'm starting to see why this is a mind-bending concept.
It is, isn't it?
Yeah.
Yeah. And this is just scratching the surface of how Deutsch uses the Infinity Hotel to challenge our assumptions about infinity and its implications for mathematics.
Well, I am definitely hooked.
Good.
This Infinity Hotel thing sounds like a great place to pick up in part 2
Perfect.
of our deep dive into David Deutsch's world of mathematics.
Looking forward to it. So you were wondering about the guest in the last room
I was.
of the Infinity Hotel.
Yeah.
That's the beauty of the analogy.
Yeah.
It forces us to confront the fact that infinity doesn't behave like any number we're used to.
It definitely challenges my everyday understanding of how things work. In the real world, hotels have a finite number of rooms.
Right.
Full is full.
Exactly.
Yeah.
Our intuition is based on finite experiences.
Right.
But the Infinity Hotel pushes us to think beyond those limitations.
You're right.
It highlights how some mathematical concepts might seem counterintuitive or even paradoxical, but they can still lead to valid and profound conclusions.
So how does this infinity hotel idea tie back to David Deutsch's view of math?
Well, Deutsch uses it to illustrate the power of abstract reasoning in mathematics.
Okay.
We can explore concepts that go far beyond our immediate physical experience, like infinity.
Right.
And those explorations can lead to breakthroughs in our understanding of the universe.
I see.
Yeah.
It's like we're stretching our minds to grasp concepts that might not have direct real-world counterparts,
Yeah,
but they still have the potential to reveal something fundamental about how things work.
precisely.
Yeah.
And this leads us to another mind-bending concept
Go.
that Deutsch explores.
Give it to me.
The multiverse.
Wait, the multiverse?
Yeah.
As in multiple universes.
Yeah.
How does that connect to math and the Infinity Hotel?
Well, the Infinity Hotel gets us thinking about boundless possibilities, right?
Yeah.
What if those possibilities extend beyond just rooms in a hotel and encompass entire universes
Whoa.
with different physical laws and histories?
Okay.
That's the essence of the multiverse idea.
Okay, my mind is officially blown.
Good.
So are we talking about parallel universes where there are infinite versions of me out there?
That's a common way to think about it, and it's definitely a fun thought experiment.
Right.
But Deutsch emphasizes that the multiverse isn't just about parallel copies. He uses the term fungible universes
Okay.
to describe how these universes might be interconnected and influence each other in subtle ways.
Fungible universes.
Yeah.
What does that even mean?
Think of dollar bills.
Okay.
They're all essentially the same, even though they have different serial numbers.
Right.
You can swap one for another, and it doesn't really matter which specific bill you have.
So you're saying these universes are kind of like interchangeable dollar bills.
It's a simplified way to think about it.
Similar, but not exactly identical.
Yeah.
Gotcha.
And this concept of fungible universes gets really interesting when we consider things like quantum mechanics.
Quantum mechanics.
Yeah,
Hold on. Are we about to dive into the subatomic world?
we are.
Yeah.
Because Deutsch argues that certain quantum phenomena are evidence that the multiverse might be real.
Okay.
Think about the double slit experiment, where a single photon
Oh, yeah. I've heard about this.
Yeah,
Yeah.
can seem to be in two places at once. It's
Oh,
like
yeah.
it's passing through both slits simultaneously.
I remember learning about that in school,
Yeah,
and it always seemed so strange and mysterious.
exactly.
Yeah.
And one way to explain this seemingly impossible behavior is through the lens of the multiverse.
Okay.
What if the photon isn't splitting in two,
Okay.
but rather interacting with its counterparts in other universes, creating this interference pattern that we observe?
So our universe isn't a closed system.
That's the implication.
It's entangled with other universes in ways we don't fully understand.
That's the mind-boggling implication.
Yeah.
And for Deutsch, this isn't just some far-out speculation.
Right.
He sees the multiverse with its fungible universes and quantum entanglement as the best explanation we have
Okay.
for certain observed phenomena.
Okay. I'm trying to wrap my head around all this.
Yeah.
So we've gone from the Infinity Hotel, which challenges our ideas about infinity,
Right.
to the multiverse, where those boundless possibilities might extend to entire universes.
Exactly.
But how does this all tie back to math?
It goes back to Deutsch's core idea that math is about seeking explanations.
Okay.
For him, the multiverse isn't just a cool sci-fi concept.
All right.
It's a potential explanation for some of the most profound mysteries of physics. And if the multiverse is real,
Yeah.
it has profound implications for how we view the nature of mathematical truth.
So the existence of the multiverse would mean that math isn't just something we invented.
That's right.
It's somehow woven into the fabric of reality itself.
That's the exciting possibility that Deutsch explores.
Wow.
He argues that the laws of physics might be a kind of computation,
Okay.
and math might be the language we use to decode those computations.
Whoa, that's a huge idea.
Yeah.
It's making me rethink everything I thought I knew about math.
Good.
So we're talking about math as a quest for explanations,
Yes.
a journey into the heart of reality itself.
You're getting it.
Okay.
And this quest leads us to another fascinating concept that Deutsch explores.
Right.
The Turing principle.
Okay.
and the idea of computational universality.
Computational universality.
Mm-hmm.
Is that about computers simulating the universe?
You're on the right track.
Okay.
The Turing principle basically states that a universal computer, given enough time and resources, can simulate any physically possible environment.
Okay.
And Deutsch takes this a step further, suggesting that this principle has deep implications for understanding the very nature of reality.
This is getting really deep.
It is.
So is Deutsch suggesting that we might be living in a giant computer simulation?
That's one interpretation. And it's a question that sparks a lot of debate.
Right.
But what Deutsch is really getting at is this idea that certain physical systems, including perhaps the universe itself, might be capable of performing any computation that's logically possible.
Okay, so back up for a second.
Sure.
What exactly do we mean by computation in this context?
Right.
Is it just about crunching numbers?
It's broader than that.
Okay.
Think of computation as any process that manipulates information according to a set of rules.
Okay.
Your brain is performing computations right now.
Yeah.
As is your phone, as is a blade of grass growing in the sun.
Right.
So it's not just about computers in the traditional sense, but about the fundamental ways in which information is processed and transformed.
So it's about change, essentially.
Exactly. And the Turing principle suggests that there might be a fundamental level at which all these different types of computation are equivalent.
Wow.
It's a pretty radical idea.
Yeah.
And it has profound implications for how we view the relationship between math computation and reality itself.
This is all incredibly mind-boggling.
It is.
We've gone from the Infinity Hotel to the multiverse.
Yes.
To the idea that the universe might be a kind of giant computer.
We have.
What a wild ride.
And we're not done yet.
Oh, no.
There's still so much more to unpack in Deutsch's ideas.
Okay.
But maybe we should take a breather and let all this sink in.
Okay.
Before we dive into the next layer of the deep dive.
Okay, I think I've had some time to digest all that.
Good.
From the Infinity Hotel to the multiverse.
Yeah.
To the idea that the universe might be a giant computer.
It's a lot to take in.
It is.
Yeah.
So where do we go from here?
Well, let's dive deeper into this idea of computational universality and its implications for math. If the universe is fundamentally computational, as Deutsch suggests, then mathematics isn't just a tool for describing reality. It's deeply intertwined with the very fabric of reality itself.
That's a pretty radical thought.
It is.
It's making me think about the relationship between math and physics.
Right?
Are you saying that the laws of physics are a kind of computation?
That's the direction Deutsch's thinking takes us.
Okay.
Imagine the universe as a system.
Okay.
Governed by a set of rules. A cosmic code, if you will.
Okay.
Mathematics might be the language we use to try and understand that code, to decipher the underlying program that drives the universe.
It's like we're looking for the source code of reality.
Exactly.
And math is the key to unlocking it.
That's a great way to put it.
Yeah.
And this connects to another fascinating concept that Deutsch discusses.
Okay.
Computable functions.
Computable function.
Yeah.
Okay.
In essence, these are functions that can be calculated by a computer in a finite number of steps.
Okay, so if a function is computable, it means we can write an algorithm to solve it.
Right.
You got it.
Okay.
But here's the catch.
Uh-oh.
There are also functions that are uncomputable.
Okay.
Meaning no algorithm, no matter how clever, can solve them.
So there are some mathematical problems that are literally unsolvable.
That's right.
Even with the most powerful computers imaginable.
Yeah, it suggests that there are limits to what we can know and compute.
That's kind of unsettling.
It is a humbling thought.
Yeah.
Even within the realm of mathematics, but,
Yeah.
you know, we have quantum computation emerging on the horizon.
Right. Quantum computers harnessing the bizarre rules of quantum mechanics.
Exact.
Could potentially crack those unsolvable problems, couldn't they?
That's the hope. They could tackle problems that are currently intractable for classical computers.
Right.
Opening up new frontiers in math and science.
Yeah.
It's like discovering a whole new set of mathematical tools that we never even knew existed.
Yeah.
So even the seemingly impossible in math could be within reach with the right tools.
Exactly.
That's incredibly exciting.
It is. And for Deutsch, this sense of endless possibility is at the heart of what makes math so compelling. He argues that embracing creativity, pushing the boundaries of knowledge, constantly seeking new explanations are essential for progress both in mathematics and in all areas of human endeavor.
I love that idea. It's like He's encouraging us to approach math with a sense of wonder and adventure.
Yeah.
Always looking for new discoveries around the corner.
Right.
It's a far cry from the dry, formulaic way math is often presented in school.
Couldn't agree more. Deutsch wants us to see mathematics not as a set of rigid rules,
Right.
but as a dynamic, ever-evolving quest to understand the deepest mysteries of the cosmos.
Well, this deep dive into David Deutsch's world of mathematics has been truly mind-expanding.
I agree.
We've explored math as a quest for explanations, the mind-bending possibilities of infinity and the multiverse,
Right.
and the idea that the universe itself might be a vast, interconnected computational system.
It's pretty amazing stuff.
It is.
There's so much more to explore in Deutsch's work.
Right.
And I encourage you to dive deeper into his writings if you're intrigued by these ideas.
I definitely will. And to our listeners, here's a final thought to ponder. If, as Deutsch suggests, the universe is a kind of cosmic computer running on mathematical principles, what does that mean for the future of humanity?
That is the question.
What incredible feats that we achieve if we can fully grasp the computational language of reality.
It's exciting to think about.
Keep thinking, keep questioning, and keep diving deeper into the fascinating world of knowledge.
Absolutely.
Thanks for joining us on The Deep Dive.